In today's video, we will be discussing about Physics Paper 1, MCQ paper 2015 May June Variant is 12 and the subject code is 9702. Question number 1. Which definition is correct and uses only quantities rather than units? Density is the mass per cubic meter. So, density is the mass per cubic meter. This statement is wrong. It would be density is the mass per unit volume. Then potential difference is the energy or the work done per unit charge. It would be charge, not current. Then pressure is the force per unit area. Yes, this statement is correct. Speed is a distance traveled per unit time. It would be time, not second. Number 2. The average kinetic energy E of a gas molecule is given by this expression, where T is the temperature in Kelvin. What are the SI base units of K? So we need to find the SI base unit of this constant K. So first of all, we need to make K becomes the subject of formula. Then energy. For energy, there are many types of energy, but I have used kinetic energy because it is easier. So kinetic energy is the half into mass into its speed square. So half into mass into its speed square. And we know the SI unit of mass is kg and the SI unit of speed square is meter square per second square divided by temperature, that is in Kelvin. So Kelvin, after arranging, we get the equation as kg meter square per second square per Kelvin, that is D. Question number 3. An analog emitter has a pointer which moves over a scale. Following prolonged use, the pointer does not return fully to 0. So this is the scale reading and this is the true reading or the true current. So following prolonged use, the pointer does not fully return to 0. That means the pointer does not return to 0 when the true current is 0. That means when the true current value is 0, the pointer reading is not 0, it is something above 0. That means when the true current reading is 0, we can see that in this axis, when the true current reading is 0, the pointer does not start with a 0 reading, it starts with a reading that is above 0 or above 0. Then, and the meter becomes less sensitive at higher current. That means at higher current, instead of starting in a straight line or moving like a straight line, the scale reading is less compared to the original value. So scale reading is less compared to the original value. So which graph best represents this result? So the result is that following prolonged use causes the pointer to does not return to 0. That means when the true reading is 0, the pointer reading is not 0. So not 0. So it will be option C or D. Then when the current, then the meter becomes less sensitive at higher current. That means at higher current, the scale reading is less. At higher current, the scale reading is less. At a higher current, the scale reading is not increasing in a proportional way or in a straight way, but as the current increases, the scale reading decreases. So here we can see that as the current increases, the scale reading increases. So this statement is wrong and the correct answer is C. Number 4. The arrow represents vector R. Which diagram does not represent vector R as two perpendicular components? So we have given the two components, that is this component and this component. If we join the vectors head to tail, that is the head of this vector to the tail of this vector, then like this. So this is our resultant vector. So this is pointing in the same direction. So this could be the answer. And we have to find that which does not represent R. So it is given this vector and this vector, again head to tail. There is the head of the vector and the tail of this vector. This is the resultant vector R. So this is also pointing in the same direction. So this could also be the answer. Then in question number D, again head to tail, the head of this vector to the tail of this vector. So we have just drawn this like in a similar way. So this is the resultant vector. So it is also pointing in the same direction. So this could be the answer, but this is not the answer, because if we join this vector's head to tail, that is the head of this vector to the tail of this vector like this, and if we join the resultant vector, then this resultant vector is pointing downward. while the value of R is pointing upward. Therefore, the wrong vector is C, that does not represent R. Question number 5. A power supply of electromotive force of 50 volt and negligible internal resistance is connected in series with a resistor of resistance 100 ohm and 5 ohm as shown. A voltmeter measures the potential difference across the 5 ohm resistor and the ammeter measures the current in the circuit. What is the suitable range for ammeter and voltmeter? So as they are connected in series, so ammeter reading is the total voltage divided by total resistance, that is 10 plus 5 ohm. So we know that current is equal to voltage by resistance. So the total voltage, that is 50 volt, by total resistance, that is 105 ohm, we get an answer that is approximately 0.47 ampere. So 0.47 is in the range, that is from 0 to 1 or 0 to 1. It is not in the range of 0 to 0.1. So 0.47 is in the range from 0 to 1. Then the voltmeter reading. What is the voltmeter reading? Voltmeter reading is the voltage across the 5 ohm resistor. So what is the voltage? We know that if we consider the voltage as V2, then V2 by V total is equal to R2 by R total. So V2 by V total, that is V2, V2 by V total is equal to R2 by R total. So we need to find the voltage. So what is the voltage? The resistance across this resistor divided by total resistance into total voltage. So we get the voltage, that is 2.38 volt. So 2.38 is in the range from 0 to 3. That is 0 to 3. So the correct option is D. In question number 6, this is an important question, so I have marked this with asterisk sign. A single sheet of aluminum foil is folded twice. So a single sheet is folded twice to form a stack of 4 sheets. So a single sheet of aluminum foil is folded twice to form a stack of 4 sheets. That is, initially it was a single sheet, then it is folded twice. That means for the first folding, that is for the first folding, it is folded in this region. So this is the first folding, and then it is again folded, so twice, so again folded to form a stack of 4 sheet. So 1 2, then this is again folded, so 3 4. So this is the stack of 4 sheet. Now for this 4 sheet, so 4, the total thickness of the stack of sheet is measured. So this is the total thickness. This measurement is made using a digital caliper with 0 error. So we have given the value of 0 error. What is the percentage uncertainty in the calculated value of thickness of a single sheet? So we need to find the percentage uncertainty for the thickness of a single sheet. So to find the value of percentage uncertainty, first of all, for the percentage uncertainty of a single sheet, so it would be uncertainty in the single sheet divided by the thickness of the single sheet into 100%. So we need to find the uncertainty of the single sheet and the thickness of the single sheet. So what is the thickness for the fourth stack? So this is the thickness for the fourth stack, and this is the zero error. So what is the thickness of the fourth stack without the zero error? So for the cancelling the zero error, there is 0.80 minus the zero error. So we need to minus this, that is 0.80 minus zero error, and we place the zero error inside the bracket, that is this negative zero error. So ultimately it would become a plus sign. So let's suppose if the zero error is positive 0.2, then 0.8 minus positive 0.2. So if we need to multiply, we need to minus the zero error from the initial reading. So for this case, 0.8 minus in bracket negative 0.2, that is positive value. So we get the thickness for the 4 sheet as this value, then uncertainty for the 4 sheet. So this is the uncertainty for 4 sheet or the 4 stack. So without the zero error. So this is the uncertainty, and we know that whenever we need to multiply, add or divide something, we need to just add the uncertainty. So the uncertainty in the true value plus uncertainty in the zero error. So we just add the uncertainty, So this is the total uncertainty for the 4 sheet, and this is the total reading for the 4 sheet. So total reading plus minus its uncertainty for the 4 sheet. So this is for the 4 sheet. So for 1 sheet, we need to divide the value by 4. So we need to divide the total value by 4. So this is the thickness for 1 sheet, and this is the uncertainty for 1 sheet. And we need to find the percentage uncertainty for a single sheet. So for a single sheet, the percentage uncertainty would be the uncertainty divided by the true value into 100%. So this is the uncertainty for a single sheet, that is 4%. In an experiment to determine the acceleration of free fall g, a ball bearing is held by an electromagnet. When the current of the electromagnet is switched off, a clock starts and the ball bearing falls. After falling a distance h, the ball bearing strikes a switch to stop the clock, which measures the time of the fall. If the systematic errors can cause the time and h to be measured incorrectly, which error must cause g to appear greater than 9.81. So we need to find which error causes g, or the gravitational resistance, to be greater than 9.81. So for this expression, we can see that we have given the value of g, then h, then t. So by using the equations that we know, s is equal to ut plus half at square, or v square minus u square is equal to as. So we do not know the value of v or the u, but we know that s is equal to ut plus half at square. And since the ball bearing is dropped, initially it is at rest. So initially it is at rest, that means u is 0. So this term is 0. So s is equal to half at square. So s is equal to half at square, that is, since it is initially at drop, so we know the equation, that is s is equal to ut plus half at square. And since it is initially given that we have not given the value of u, so we can consider that u is 0. So initially it is at rest. So s is equal to half at square. So which value affect the acceleration to be greater than 9.81? So if we just make the acceleration becomes a subjective formula, the acceleration is equal to 2s by t square. And now by considering this equation, which value gives the value of acceleration that is greater than 9.81? So which value makes acceleration greater value? So for the acceleration to be greater, s value would also have to be greater and time had to be less. So h measured as being smaller, so this is not smaller, this is larger. So larger or correctly, so it is either larger or it is either correctly. And t is not smaller, t is smaller, t is not larger, t would be smaller, the rest t is smaller. So h is measured correctly, okay, this value is constant, and time is smaller. Since time is smaller and acceleration is inversely proportional to time square, so if time decreases, acceleration increases, that means the acceleration value is greater than 9.81. So the answer is D. Number 8. A stone is thrown horizontally. So a stone is thrown horizontally from the top of a cliff and the air resistance is negligible. Which graph shows the variation with time of the vertical component of the stone's velocity? So initially it is at the top of a cliff. So this is the cliff and this is the stone. So this is dropped horizontally. Since it is dropped horizontally, that means the initial vertical component of velocity. So we need to find which graph for vertical component of velocity, that is v, and the stone is thrown horizontally, that is vh. So as the stone is thrown horizontally, that means it has some horizontal component of velocity, but the vertical component of velocity is 0 since it is not thrown at an angle or vertically. So initially it has horizontal component of velocity and the vertical component of velocity is 0. And these graphs are all for vertical component of velocity, that is for the vertical component of velocity. So initially the vertical component of velocity is 0. So this is not 0. Then these three all are 0. Then we have given that air resistance is negligible. Since air resistance is negligible, that means the acceleration is constant, that is 9.81. Since acceleration is constant, that means the gradient of the velocity time graph is also constant. So the gradient have to be constant and a straight line, that is in option D. But in option C, we can see that the gradient decreases, so the acceleration decreases. So this statement is wrong. And here gradient increases, so acceleration increases. This is wrong, because as air resistance is negligible, so acceleration is constant, that is 9.81. 9.81. So in this graph, acceleration or the gradient is constant. Question number 9. A sprinter runs a 100-meter race in a straight line. He accelerates from the starting block at a constant acceleration of 2.5 meter per second square to reach a maximum speed of 10 meter per second. So he starts from a starting block or from rest. So he starts from a rest and he has an acceleration of 2.5 meter per second square, that is constant acceleration. So acceleration is constant. So if you draw the velocity time graph, gradient is acceleration, so gradient is constant or acceleration is constant until it reaches a maximum speed of 10 meter per second. Then he maintains the speed until he crosses the finishing line. So he maintains this speed. Which time does it take for the sprinter to run this race? So what is the time? To find the total time for this race, first of all, we need to find the time taken for the acceleration. So we know the value of acceleration, that is 2.5. So we know that acceleration is equal to velocity by time. So time is equal to velocity by acceleration. So we know the value of velocity, that is 10. And we know that the value of acceleration is 2.5. So 10 divided by 2.5. So we get the value of acceleration, that is, so we get the value of time, that is 4 seconds. So velocity by 2.5. So velocity by 2.5 is the value of time. So this is the time for acceleration. Then what is the distance covered during this acceleration? So to find the distance is the area under the velocity time graph, and this area is the area of the triangle. So distance is equal to half into area of the triangle. So base is 4. So base into height. So the height is 10. So we get the distance value, that is 20 meter. So during acceleration it travels 20 meter and the total distance is 100 meters. So 100 minus 20 gives us a distance, that is 80 meter. So now he needs to cover 80 meter to complete this race with this constant speed. So what is the time for this constant speed? So to find the value of time, we know the equation, that is velocity is equal to distance by time. So time is equal to distance by velocity. So we know the distance, that is 80 meter. So he needs to cover 80 meter during maintaining this constant speed, that is 10. So we get the value of time, that is 8 seconds. So in total, 8 seconds plus 4 seconds, that is 12 seconds is the final answer. 10. A firework rocket is fired vertically upwards. The fuel burns and produces a constant upward force on the rocket. So the fuel burns and produces a constant upward force F on the rocket. After 5 seconds, there is no fuel left and air resistance is negligible. What is the acceleration before and after 5 seconds? So here it is mentioned that air resistance is negligible. And what is the acceleration of the fuel before and after 5 seconds? So if let's suppose this is our rocket, then as the fuel is burned, the rocket is moving upwards. So the weight of the rocket is acting downwards and a constant upward force is acting upwards. So force is acting upward and weight is acting downwards. And as we know that resultant force is equal to mass into acceleration, that means the resultant force here is forward force minus backward force is equal to mass into acceleration. That is forward force minus mg is equal to mass into acceleration. So this is our original equation to find the values. Now from this equation, as we know that the fuel is burnt. So as fuel burns, so normally it has some mass, but as fuel burns, the fuel is being used and so the mass decreases. Since the mass of fuel is lost, so the mass decreases. So mass decreases. Now if we rearrange this equation, then force is equal to ma plus mg. And here mass is decreasing as the fuel is burnt. That means before 5 seconds, as the fuel is burnt, mass is decreasing. And here it is mentioned that the force is constant. So this force is constant. That is, this is constant. Now this force is constant and mass is decreasing. And so what is the acceleration? This force is constant, and so left hand side is constant. And to make the right hand side constant, G is obviously constant since G is the gravitational field strength, that is 9.81. So G is constant, mass is decreasing. That means to make the right hand side equals to the left hand side, as force is constant, so acceleration must increase. Since mass is decreasing, so acceleration must increase in order to balance the left hand side is equal to right hand side. Therefore, acceleration is increasing. That is, as the force is constant, G is constant, and mass is decreasing. So to make the left hand side is equal to right hand side, acceleration must increase. Therefore, acceleration is increasing. And after the 5 seconds, that is all the fuel is being used up, forward force is equal to mass into acceleration plus mg. That is, I write this equation. So for this equation, the fuel is being used up. So now the mass is the mass of the rocket, and the mass of the rocket is constant. So mass of the rocket is constant, then g is also constant, and as the fuel is being used up, there is no forces acting, so the force is 0. As the force is 0, so if we rearrange this equation, then mass into acceleration is equal to negative mg. And since force is 0, so mass into acceleration is equal to negative mg. And gravitational field strength is constant, mass is constant. As the mass is constant on both the sides, so we can cancel each other out, and acceleration is equal to negative g, that is negative gravitational field strength. And gravitational field strength is 9.81, that is negative 9.81. So as we can see that acceleration is also constant, that is the negative gravitational field strength. Therefore, acceleration is constant. So the answer is C. Question number 11. Trolley X, moving along a horizontal frictionless surface, collides with a stationary trolley Y. So Y is stationary. The two trolleys become attached and move off together. So they move off together. Which statement about this interaction is correct? So first of all, we know that momentum is always conserved, and since it is not an elastic collision, so kinetic energy is not conserved. So kinetic energy is not conserved, but momentum is always conserved. Sum of the kinetic energy of trolley X is changed to the momentum in the collision. So this is not changed to the momentum, it is changed to the kinetic energy of Y. Since Y is stationary, now Y is moving, so sum of the kinetic energy of X is changed to the kinetic energy of Y. Sum of the momentum of X is changed to the kinetic energy in the collision. This is wrong because momentum is always conserved, it is not converted to energy. Trolley X loses some of its momentum as heat in the collision. It is not momentum, it is kinetic energy. That is, trolley X loses some of its kinetic energy as heat in the collision, since it is not an elastic collision, as it is not mentioned. Trolley X shares its momentum with trolley Y, but some of its kinetic energy is lost. Yes, this statement is correct, since we can see that momentum is equal to mass into velocity, and trolley X shares its momentum with trolley Y. That means initially X has velocity, and since X has velocity, therefore X has some momentum, since mass into velocity is momentum, and Y has no momentum since its velocity is 0. And after the collision, both the objects move, and so both have some momentum. So trolley X shares its momentum with trolley Y, and but some of its kinetic energy is lost. Since it is not an elastic collision, so some of the kinetic energy is lost as heat. Therefore, the statement D is correct. 12. An astronaut throws a stone with a horizontal velocity near to the moon's surface. So he throws with a horizontal velocity. Which row describes the horizontal and the vertical forces acting on the stone after release? So it mentions after release. That means initially at the top, or initially the astronaut throws the stone horizontally. So he throws the stone horizontally, and after throwing, that is after release, that means suppose at this point, as he throws it horizontally, after release, that means after this point, that means he has released this stone at this point. So here we can say that no horizontal force is acting, since he has already released, and so no other force is acting in the horizontal direction, so the horizontal force is 0. But what is the vertical force? So for this stone, we know that there is some gravitational field strength on the moon's surface. Since there is some gravitational field strength on the moon's surface, therefore there must be some weight, that is mass into gravitational field strength. So the vertical force, that is the weight, is constant. Since mass is constant and gravitational field strength is constant, therefore weight is also constant. Therefore the answer is C. Question number 13. Newton's third law of motion is often summarized as every action has an equal and opposite reaction. A book rests on a table. If the weight of the book is the action force, what is the reaction force? So, if the weight of the book is the action force, what is the reaction force? So, if object A exerts a force on object B, then object B will exert an equal and opposite force on body A. So, that means the forces are of equal magnitude, acting in opposite direction and acting in opposite bodies. So, if the weight of the book is the action force, weight is the action force. And what is weight? Weight is the pull of the earth on the book. Weight is the pull of the earth on the book. So, weight is the pull of the earth on the book. So, what is the reaction force? So, the reaction force would be pull of the book on the earth. So, weight is the pull of the earth on the book. There is pull of the earth on the book. So, pull of the earth on the book. So, the reaction force would be pull of the book on the earth. Therefore, the answer is A. Question number 14. A ladder is positioned on an icy, frictionless ground. So, the ground is frictionless and is leaned against a rough wall. At the instant of release, it begins to slide. Which diagram correctly shows the direction of force P, W, and R acting on the ladder as it slides? So, the ladder is positioned on the icy frictionless ground. That means the ground is frictionless. That means here the ground, there is no friction. Since there is no friction, so the only force acting by the ground is the normal reaction force. That is the normal reaction force acting vertically upward. So the normal reaction force have to be acting vertically upward. Therefore, answer C and D are wrong. And is leaned against a rough wall. So as the wall is rough, that means there is some friction. That is, friction is equal to mu r. So as the wall is rough, that means there is some frictional force. Also, there is a normal reaction force, that is vertically upwards. So there must be a normal reaction force, that is vertical upward, and a friction. And as the ladder is moving downward, so the friction must act upward. So friction is acting upward and normal reaction force is acting vertically or perpendicular. So the normal reaction force is perpendicular, that is, normal reaction force is perpendicular, and since the ladder is moving downward, so the friction is acting upward. So the resultant of both the forces would be the force in this direction. So the force would be the force P, that is the correct force by the rough surface on the ladder, and the weight is acting vertically downwards. So the answer is B. Question number 15. A uniform solid block has a weight 500 Newton, width 0.4 meter and a height of 0.6 meter. The block rests on the edge of a step of depth 0.8 meter as shown. So this step is 0.8 meter as shown. The block is knocked over the edge of the step and rotates through 90 degrees before coming to rest with the 0.6 meter edge horizontal. So initially the 0.6 meter is the vertical, now it becomes horizontal. What is the change in gravitational potential energy of the block? So change in gravitational potential energy is equal to mass into gravitational field strength into height, that is weight into height. Since we know the value of weight, so mass into gravitational field strength is the weight into height. And so the weight is, since the solid is uniform, that means the weight is acting at the center, that means at this point. And when it is at this point, the weight is acting at the center, that is at the middle. So this is the middle and this is the middle. So what is the change of weight? The gravitational field strength of the weight, that is the of the block. So if we consider this point as the position of weight, so we have to consider the height from this point. So the height from this point to this bottom is 0.3 meter. So 0.3 meter, that is the half of this height. Since it is a uniform rod, so half of this height, that is 0.3 meter. Then this weight comes to be this point, that is from this point to this point. So what is the change in gravitation, change in height from this point to this point? 0.3 meter plus this height. And what is this height? So this total height is 0.8. That means this height is 0.4. So 0.8 minus 0.4, that is this height is 0.4. So we know the value of this height. Now what is this change in height? Since it is the uniform block, so this height is, since the total is 0.4, so 0.4 by 2, that is 0.2. So what is the total height? 0.3 meter, that is this height, plus 0.4 plus 0.2. So in total we get a total height, that is 3479. So 0.9 meter. So we know the value of height, that is 0.9 meter, and the weight is 500. So if we multiply, we get the gravitational change in gravitational potential energy as 450 joules. So the answer is C. 16. The diagram shows a hydroelectric power station. The receiver is linked to the turbine by a pipe of uniform cross-sectional area, that is this pipe. Water flows from X to Y, so from point X to point Y at a constant speed. Since speed is constant, so we'll discuss this later. Which statement about the change in energy of water as it moves from X to Y is correct? So gravitational potential energy is equal to mass into gravitational field strength into height. Kinetic energy is equal to half mv square, and here it is also mentioned elastic potential energy. So elastic potential energy is equal to half fx or half kx square. So for the change in energy, we can see that the speed is constant. Since speed is constant, also mass is constant, therefore the kinetic energy is also constant. So there is no change in kinetic energy. While as we can see that the vertical height from X to Y decreases, so the gravitational potential energy also decreases. So it gains gravitational potential energy. This is wrong. It loses elastic potential energy and kinetic energy. So kinetic energy is constant. Then it loses elastic potential energy and gravitational potential energy. Yes, gravitational potential energy is lost. Then it loses gravitational potential energy and gains elastic potential energy. Now, energy is always conserved. Since energy is conserved and gravitational potential energy is lost, so gravitational potential energy is lost, so it must gain some other energy. So since energy is conserved and gravitational potential energy is lost, so it must gain elastic potential energy in order to make the energy constant. So the answer is D. Number 17. A fisherman lifts a fish of mass 250 gram. That is, if you need to convert this to kilogram, that is 250 by 1000, that is this much kilogram, from rest through a vertical height of 1.8 meter. So the vertical height is 1.8 meter, that is h. The fish gains the speed of 1.1 meter per second. What is the energy gained by the fish? So as it is moved a vertical height, so it must gain some gravitational potential energy. Also it has some speed. It starts from rest and it has some speed, so it has some kinetic energy. So gravitational potential energy is equal to mass into gravitational field strength into height, and kinetic energy is half mv square. So gravitational potential energy, there is mass into gravitational field strength into height, there is the vertical height, and kinetic energy half m, and so the mass m or the mass must be in kilogram, so half m, and the gain in speed square. So in total the increase in energy is 4.6 joules. Question number 18. Water from a receiver is fed to the turbine of a hydroelectric system at a rate of 500 kg per second, that is the mass, and the receiver is 300 meter above the level of the turbine, so the height is 300 meter. The electrical output, so this is the output from the generator, is driven by the turbine, is 200 ampere, that is the current at a potential difference of 6000 volt. So this is the potential difference, that is V. What is the efficiency of the system? So efficiency is the useful energy output divided by total energy input in 100%. So what is the output energy? That is electrical energy output. So output is the electrical energy. So output is the electrical energy, that is power into time, that is voltage into current into time. and we know the value of voltage, we know the value of current, and what is time. Since it is mentioned that this much kg per second, so we take the time as 1 second. So this is the energy output, that is the output energy. So this is the output energy. So this is the output energy, that is 1.2 into 10 to the power 6. Then what is the input energy? As we can see that mass, and we know the value of height. So the input energy is the gravitational potential energy, that is mass into gravitational field strength into height. So we know the value of mass, gravitational field strength, that is 9.81, and the vertical height is 300 meter. So this is the gain in this is the energy, that is the gravitational potential energy provided, and the water at this point is dropped, and as it is dropped, so gravitational potential energy is changed to kinetic, gravitational potential energy is changed to electrical energy, since the output is the electrical energy. So output is the electrical energy, that is 1.2, and the input is the gravitational potential energy, that is 1.47. So 1.47 into 100%, that is efficiency is useful energy by total energy into 100%. So the efficiency comes to be 82%. Question number 19. Which row correctly describes the ordering and the motion of molecule in liquid water and in ice when both are at a temperature of 0 degrees centigrade? So ordering and motion. So ice, since it is a solid, so the ordering is regular pattern, while water is a liquid, so it moves randomly within the liquid. So the ordering for ice is regular pattern for ice, but not for water. So this statement is, this option is correct. Then regular pattern for ice but not for water, this is also correct. The regular pattern for both water and ice, this is wrong. This is wrong because water can move randomly within the liquid, but the ice is in regular arrangement. And what is the motion? So since they are at the same temperature, that is 0 degrees centigrade, and since temperature is same, so temperature is related to kinetic energy. Since temperature is same, so kinetic energy is also the same. So the average speed of both water and ice is same. That is option A. 20. The maximum pressure the granite rock can withstand is 20 to the power 8 Newton per meter square or Pascal. Above this pressure, the rock begins to flow like a liquid. The density of granite is 2.7 into 10 to the power 3. That is the density. What would be the height of a pure granite mountain whose base is just beginning to flow? So we need to find the height. So basically, for this question, we know the pressure, we know the density. So we can use pressure is equal to rho gh, where we know the value of pressure, we know the value of density, and we need to find the value of height, and we know the gravitational field strength, that is 9.81. So after substituting the value, we get the height as 7.55 into 10 to the power 3, that is 7.6 into 10 to the power 3 meter. In question number 21, to determine the Young modulus of a wire, several measurements are taken. In which row can the measurement not be taken directly with the stated apparatus? Measurement and apparatus. So in which row is the measurement not taken directly? So the measurement is not taken directly with the stated apparatus. So area of the cross section of the wire. So we know that area is equal to pi d square by 4, and using the micrometer screw gauge we can measure the diameter, and by using this equation we calculate this area. So we cannot use micrometer screw gauge to calculate area directly, because first we have to use the micrometer screw gauge to calculate the diameter, or to measure the diameter, then use it to calculate the area. So that's why the option A is wrong. While vernier caliper or the vernier scale is used to measure the extension of the wire, and electronic balance is used to measure the mass. Yes, this is true. And meter rule is used to measure the original length. Yes, this is true. But micrometer screw gauge is used to measure the diameter, and by using this diameter we measure we calculate the area. That's why it is not measured directly. Therefore the answer is A. Question number 22. A long thin metal wire is suspended from a fixed support and hangs vertically. The masses are suspended from its lower end. The load on the lower end is increased from 0 and then decreased again back to 0. The diagram shows the force extension graph produced. So basically the statements are about force extension graph. Where on the graph would the elastic limit be found? So for the force extension graph, we know that force is directly proportional to extension when the graph or the wire obeys Hooke's law. That is, this is the limit of proportionality where the graph starts to become non-linear. That is, the graph starts to become non-linear, though after the limit of proportionality there is a point that the elastic limit, and from the elastic limit the wire can return back to its original length. So from the point of elastic limit the wire can return back to its original length, and as we can see that from t the wire does not return to its original length and some extension is remained. Therefore point t is not the elastic limit. So elastic limit is not point t. Then at point S, this is the limit of proportionality, so this is wrong. And elastic limit is after point S, so anywhere between a point R and point S. So point R and point S, this option is wrong, because if the point is at this point, then this is not the elastic limit, because elastic limit comes after the limit of proportionality. So just beyond point S, so just beyond point S there is an elastic limit where the after the at the point of elastic limit the wire can returns to its original length. So just beyond the point S but not at point T, because as we can see that at point T the wire does not return to its original length. Therefore this is not at point T and just beyond point S before point T. So the answer is B. Question number 23. The diagram represents a steel tube with the wall thickness W, that is the thickness W, which is small in comparison with the diameter of the tube. The tube is under tension caused by a force T, so the force is given, that is T, parallel to the axis of the tube. To reduce the stress in the material of the tube, it is proposed to thicken the wall. The tube diameter and the tension being constant, so the diameter and the tension being constant, which wall thickness will give half the stress. So we need to get half the stress. So we know that stress is equal to force per unit area, and the force that is given is tension T. So the tension T by area. And what is the area? So if we just open the circular or the steel tube and just open this end, and if we just arrange this in terms of rectangle, then this W is the width and this length is the height. And what is the length of this tube? So length of the tube is equal to the circumference of the circular object. So what is the circumference? Circumference is 2 pi r. So circumference is 2 pi r, that is this circumference. So circumference is this 2 pi r. So this length is same as this length, that is 2 pi r. So what is the area? Area is equal to length into width. So for the rectangle the area is equal to length into width, that is 2 pi r into W. So 2 pi r into W. So it is given that the diameter and the tension is constant. So the tension is constant and the diameter, that is r, is constant. Since diameter is constant, so radius is also constant, and 2 pi is already constant. So stress is inversely proportional to width. This stress becomes inversely proportional to width. So if the stress is half, then the width is obviously doubled. Since stress is inversely proportional to width, so if stress is half, then width is obviously doubled. So it is 2W. 24. Two light waves of the same frequency are represented by the diagram. What could be the phase difference between the two waves? So the waves have the same frequency, that is f, and they both are light wave, so they both have the same speed. So v is equal to f lambda. So they have the same frequency, they have the same speed, that means they have the same wavelength. So wavelength is same. What could be the phase difference between the two waves? So for the phase difference is usually calculated as the difference in distance by wavelength into 360 degree. But here we have given not the distance but the phase angle. So we have given the phase angle and we know that both have the same wavelength. So we have given the phase angle, that is this point starts from 0 degree while this point starts from 100 degree. So what is the phase difference? The phase difference is 100 degree. So the phase difference is 100 degrees, so the answer should be 100 degree, but this is not given. So 100 degree is also equivalent to 360 minus 100, that is 260 degree. So the answer is C. In question number 25, a sound wave has a speed of 330 meter per second and a frequency of 50 Hz. What is the possible distance between the 2 points of the wave that have a phase difference of 60 degree? So we know the value of phase difference, speed and frequency. So phase difference is equal to approximate change in distance by lambda into 360 degree. And we know the value of phase difference. We need to find the difference between the 2 points, or the distance between the 2 points, that is the approximate change in distance or the distance between the 2 points. But we need to find the lambda to find this value. And what is the value of lambda? V is equal to f lambda. So lambda is equal to v by f. So the lambda comes to be 6.6 meter. Lambda 6.6. Phase difference is 60 degree. And approximate change in d, there is the distance between the 2 points into 360. So the distance between the 2 points comes to be 1.1 meter, that is b. Question number 26. What is not an essential condition for an observable interference pattern to occur between two waves from two sources? So, to discuss this, first of all, what is interference? Interference is where two or waves meet or overlap to form a resultant wave, and the resultant displacement is the sum of the individual displacement. So, interference is where two or more waves meet to form a resultant wave, two or more waves meet to form a resultant wave, and the resultant displacement at any point is the sum of the individual displacement. So the resultant displacement is the sum of the individual displacement. And for interference to occur, the sources must be coherent, and coherent means constant phase difference. So the waves must have constant phase difference. So they must have constant phase difference, that is, also for the waves to be coherent, they must have the same wavelength, same frequency, and since they have the constant phase difference, that means the waves must have to be in phase. So you must have to remember that for the wave to be coherent, these properties are needed. That is, they must have a constant phase difference, or they must be in phase, and they have the same wavelength and frequency. So the frequency of the two sources must be equal. Yes, this is important for coherent, and so it is important for interference. The sources must be coherent. Yes, for interference to occur, the sources must have to be coherent. Then the sources must emit waves of equal amplitude. This is not the case because the amplitude can be different. So the answer is C, that is not the essential condition. And the waves from the two sources must overlap. Yes, this is necessary for interference because interference occurs when waves overlap. So the wrong answer is C. 27. Sources emits microwaves with a constant amplitude. The microwave hit a metal screen P. There is a metal screen P and reflected. A stationary wave is formed between S and P. So between S and P, stationary wave is formed. That is stationary wave. The wavelength of the microwave is much smaller than the distance between S and P. So suppose this is the distance between S and P and the wavelength is much smaller. Suppose this length is the wavelength and the data Q is moved at a slope constant speed from S to P. What happens to the amplitude of the signal detected by Q? So what happens to the amplitude of signal detected by Q? So as stationary wave is formed, so at this point node, 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 node. So nodes are detected. That means the amplitude is 0. And at this point antinode, that means the maximum amplitude. That means as the detector moves, it increases from 0, then decreases, then again increases from 0, then again decreases, then again increases from 0. So it increases and decreases regularly. So the answer is B. Number 28. The pattern of the wave are observed without being able to view the source of the wave. The pattern is represented in the diagram. So this is the pattern formed: region of minimum intensity, region of maximum intensity. So region of minimum intensity and maximum intensity, what can cause this pattern? So coherence, that means constant phase difference. This is not the case. Then diffraction, okay, we can see that the diffracted waves, so it could be diffraction. And interference, there could be interference since as the waves are diffracted, there is maximum and minimum are detected. So there could be interference. So the waves are diffracted as well as since maximum and minimum are detected. So where the interaction occurs, that means constructive interference occurs, maximum is detected, and where destructive interference occurs, minimum is detected. So the answer is B. There is interference, so the interference can be constructive where maximum is detected, the interference can be destructive where minimum is detected, and diffraction as the waves can be seen that it is diffracted. Question 29 is related to electric field, so this is not in our syllabus. Then question number 30 is also related to electric field, so this is not in our syllabus. Then question number 31, which unit is not used in either the definition of Coulomb or the definition of volt? So which unit is not used in the definition of Coulomb? So Coulomb is the unit of charge and charge is equal to current into time. So Coulomb would be ampere second. That is the current is ampere and the time is second. Then volt is the unit of voltage and voltage is equal to watt done per unit charge or energy per unit charge. So the unit of energy is joule and the unit of coulomb is charge. The unit of charge is coulomb. So ampere is needed for the definition of coulomb. So this is needed. Also joule is needed for the definition of volt. Second is needed for the definition of coulomb. But ohm is the unit of resistance and resistance is not used in the definition. It is used for the derivation but it is not used for the definition. Therefore the answer is that is wrong is C. Number 32. When a thin metal wire is stretched, it becomes longer and thinner. So it is the initial length of the wire and when it is stretched, it becomes longer and thinner. So the wire becomes longer and thinner, that is longer and thinner. This causes a change in the resistance of the wire. The volume of the wire remains constant. So the volume of the wire remains constant, which graph would represent the variation of with extension of the resistance of the wire. So which is the graph is of the resistance against extension. So volume is constant and we know that volume is equal to area into length. That is the cross-sectional area into length. And the volume is constant. So volume is constant. And for resistance, we know that resistance is equal to resistivity into length by cross-sectional area. So if we replace the cross-sectional area by this area, that is area is equal to volume by length, we get this expression. And for this expression, volume is constant. Resistivity, since the metal wire is same, so the resistivity is constant. So resistance is directly proportional to length square. As resistance is directly proportional to length square, so the graph should be like this curve. That is, resistance against length graph is this curve. But since it is not the graph of resistance against length, it is the graph of resistance against extension. So it should start from a value that is above 0. That means when the extension is 0, that means this original wire, when the extension is 0, it has some length and due to this, it has some resistance. Therefore, it must start from above value and it increases. 33. Which statement is not valid? So current is the speed of the charged particle that carry it. So current is equal to charge by time. So it is not the speed of the charged particle. That's why this is wrong. And current is equal to charge by time. So this is wrong. That is charge per unit time. Then EMF is watt done per unit charge. So watt done or energy converted from electrical to other form of energy per unit charge. So this statement is correct. Then potential difference between 2 points is the watt done per unit charge. So potential difference is the watt done per unit charge. When moving the charge from one point to another, there is potential difference is equal to watt done per unit charge. Then resistance between 2 points is the potential difference between the 2 points per unit charge. So resistance is equal to potential difference, that is PD, by charge per unit current, that is I. So resistance is equal to potential difference per unit current. So this is true. So the wrong answer is A. 4. A cell of EMF E delivers a charge Q in the external circuit. Which statement is correct? The energy dissipated in the external circuit is EQ. So what is energy? Energy is equal to power into time. So the capital E is represented by EMF. That's why we represent energy as small e. So energy is equal to power into time. So voltage into current that is VI T, and current into time, that is current is equal to charge per unit time. So charge is equal to current into time. Here is V and Q. Charge is equal to current into time, that is VQ. And V is represented by E. So EQ. So the energy is represented by EQ. That is energy distributed in the cell and the external circuit is EQ. So the answer is D. Number 35. Each of the Kirchhoff's two law presumes that some quantity is conserved, which row states that the Kirchhoff's first law and the name of the quantity that is conserved. So quantity that is conserved for the first law is charge, and the algebraic sum of current into a junction is 0. So the sum of the current entering a junction is equal to the sum of the current leaving a junction. That's why the total sum is 0. And this is not the EMF. 6. A potential divider circuit consists of a fixed resistor of resistance 2 ohm and 4 ohm connected in series with a 3 ohm resistor fitted with a sliding contact. So the 3 ohm resistor is fitted with a sliding contact and 2 ohm and 4 ohm resistors are given. These are connected across a battery of EMF 9 volt and a 0 internal resistance as shown. What is the maximum and the minimum output voltage of the potential divider circuit? So we know that the equation, that is V2 by V total, that is V2 by V total is equal to R2 by R total. So V2, that is the voltage across this resistor, is equal to R2 by R total into V total. So for the maximum voltage, the resistance have to be maximum. That's why this is chooses the largest point. So if the sliding contact is at this point, so the total resistance covered by the sliding contact is 2 ohm plus 3 ohm, that is 5 ohm, that is R2, that is 5 ohm, and the total resistance is 9 ohm, and V total is 9. So the total voltage that we get, the maximum voltage is 5 volt. So the maximum voltage is 5 volt. What is the minimum voltage? That is, if the sliding contact is at this point, then it covers the area that is, so it covers the area that is at this point. So the resistance is 0 for this resistor, but it covers this resistor. So this resistor has a resistance of 2 ohm, that is R2 by R total is 9 ohm, and the voltage is 9 volt. So the total voltage is 2 volt. So the voltage is 2 volt and the answer is B. 7. The cell has a EMF of 2 volt. There is 2 volt and negligible internal resistance is connected to a network of resistors as shown. So this is the circuit shown. What is current I? So we need to calculate the value of current I. To calculate the value of current I, first of all, what is the resistance across the parallel circuit? So resistance is equal to 1 by 4 plus this is also 1 by 4 inverse. So the resistance across the parallel circuit is 2 ohm. That is, this resistance is 2 ohm. Now this resistance is 2 ohm, that is the resistance in this combination is 2 ohm and this resistance is 2 ohm. So in total in this parallel circuit the resistance is 4 ohm. So we know the value of resistance, and since in parallel circuit the voltage remains the same, that means in this circuit the voltage is 2 volt, in this circuit the voltage is also 2 volt. So we know the value of voltage, that is 2 volt, and we know that resistance is equal to voltage by current. So we know the value of resistance in this circuit or this part of the junction, that is the resistance in this junction is 4 ohm. It is 4 ohm and voltage is 2 volt, that is 2 volt. There is this total voltage is 2 volt. Now we know the voltage and the resistance. So what is current? So the current in this junction is represented at I. So as this current is I and it has a resistance of 4 ohm, that means it also has a resistance of 4 ohm. That means it has also a current of I. So the resistance in combination here it would be 2I. So 2I is divided into I and I. So that means in this part of the circuit the current is 2I. So 2I. So if we just calculate, then 2 and 2 cancels and I is equal to 1 by 4, that is 0.25. Method 8. In an experiment in which alpha particles are deflected by the gold foil produce new insights into the structure of an atom. Which conclusion can be drawn from the result of this experiment? So this is not about the electrons, then different number of neutrons, this is not for different number of neutrons, then this is not about protons and neutrons. So the correct statement is A, that atomic nuclei occupy a very small fraction of the volume of atom. Since the atomic nuclei is small, so most of the alpha particles remain undeflected and some of it is deflected. That's why the answer is A. Then the radioactive substance contains a number of identical nuclei that emit beta particle. So it emits beta particle which property of this nuclei remain unaltered by the emission. So which quantity is unaltered? So if let's suppose beta minus decay occurs, then beta minus decay, so neutron, that is neutron changes to a proton, that is 1 1. So charge is balanced, and since beta minus is emitted, so an antineutrino is emitted, and if beta plus is emitted, then neutrino is emitted. Beta minus, antineutrino, beta plus, neutrino, and proton changes to a neutron. So which property of the nuclei remains unaltered? So what is not changed? So charges change, since as we can see that the charge transfers occurs since beta minus particle is emitted or beta plus is emitted, so there is a change in charge. So neutron number. So as we can see that neutron changes to a proton, so neutron number is affected. Also proton changes to a neutron and neutron changes to a proton, so proton number is affected. But the total number of proton and neutron remains unaffected. Number 40. A uranium-238 nucleus undergoes a nuclear decay to form uranium-234 nucleus. Which series of decay could give this result? So, which series of decay could give this result? So, as alpha particles are emitted, the nucleon number decreases by 4 and the proton number decreases by 2. And as beta minus particles are emitted, there is no change in nucleon number, but the proton number decreases by -1. That is this decay. Now, as we can see that 238 is converted to 234, that means there is a decrease in the 4 of the nucleon number. That means 1 alpha particle is emitted. So, the emission of 1 alpha particle, and there is no need for gamma radiation. So, either alpha or beta. So, 1 alpha particle is emitted, that is answer C. And as 1 alpha particle is emitted, proton number decreases by 2. So, proton number decreases by 2, but as we can see that proton number is the same. That means as beta minus occurs, so 2 beta minus particle is decayed. So that means 2 neutrons changes to 2 proton, 2 beta minus particle and 2 antineutrino. And as 2 beta minus particles are emitted, proton number is balanced. So initially proton number decreases by 2, now proton number increases by 2. So overall proton is same and 2 beta minus particle is emitted, so 2 beta minus particle.